Okay, so chain rule. This is probably the most important rule that we're going to go over in this unit. And this is also the rule that's most often missed or forgotten. Here's why this rule is useful. So I've given you 4 functions here, and if I were asked to ask you to take the derivative of any of these, you could do it, except for this last one. So here what you might do is you might multiply this together, or use product rule, right, to tackle this, and you could take that derivative. Same thing here. You could do product rule twice, or multiply everything together, although it would be tedious. So, yes, yes. Same thing to the 6th power. The answer here is also yes, although it would be really annoying. So you could go through and by hand multiply this by itself 6 times, or you could do product rule, I guess 5 times. So we could say yes, but annoying. And then here, even if I rewrote this as 2x to the 5th to the 1/2, we don't know how to do that yet, okay? The chain rule will help us solve all of these, including this new one that we could not solve with our current knowledge. So the chain rule we use when you have a function within a function. And this is sometimes hard to see. So what I mean by that is 2x plus 5 is a function, but also x squared is a function, or something squared is a function, right? So it's as if I took 2x plus 5 and I shoved it into x squared, right? You know how to write this down already. We call it compositions in pre-calc. So the way we write a function within a function is f of g of x. And we're taking the derivative of that, of f of g of x. All of these are functions within functions. The rule is the derivative of f of g of x is f prime of g of x. So the derivative of the outside and then the inside stays the same, times g prime of x. Okay? So derivative of the outside, inside stays the same, and then we multiply by the derivative. Okay? So now with the chain rule, for our first one, we're going to say f prime of x. We're going to take the derivative of the outside function, which is x squared. So multiply by 2 and then subtract 1 from it. Inside stays the same. We have an invisible 1 up here. And then I want to multiply times the derivative of the inside. Well, the inside is this. So the derivative of my inside then is 2, right? Derivative of 2x plus 5 is 2. Okay, so my result is f prime of x equals 2 times 2 is 4 times 2x plus 5. And I could even multiply that through if I wanted. And you could check if I took the, if I squared this and then took the derivative or took it via product rule, you get the same thing. Except for 4 times 5 is 20 and not 40, right? You guys probably caught that. Okay. We'll do, B would look really similar, right? We'll do C though. So C, this is A. So f prime of x. I'm going to do power rule for the outside. So it's going to be 6 times 2x plus 5. Inside stays the same. And then 6 minus 1 is 5. And then times that inside derivative of again. So that 2. Okay. And then this one I'm not going to simplify too much. I'm just going to multiply those together. So f prime of x would be 12, 2x plus 5 to the 5th. Okay. And then D. So I have 2x to the 5th, or 2x plus 5 to the 1/2 power. So same thing as before. I'm going to multiply by my exponent. Inside stays the same. And then subtract 1 from my exponent. So power rule. And then times that derivative of the inside. So what's happening is the outside function is sort of compounding the changes of the inside function. And this, of course, is f prime of x. So that is chain rule. Where this gets harder, so I think you guys are going to be good like just following the steps. Where students tend to struggle is by following the rules when I give you a graph or a table. The trick here is to write the derivative first. So don't try to do it just in your head. Write the derivative out for these using chain rule. So what I mean by that is if h of x is f of g of x, and we want h of prime of 4, the first thing we're going to do is just write that h prime of x, and we're going to follow the model, right? So h prime of x is going to be f prime of g of x times g prime of x, right? So the derivative of the outside, inside stays the same, times the derivative of the inside. And then, if we want h prime of 4, well, that's going to be f prime, now I can just plug this in, right, of g of 4 times 4. Okay, so notice now, I have to work from inside to outside. So f prime, I'm going to leave alone for a second, and then g of 4 I'm going to evaluate. So g of 4 from the table is 2, so f prime of 2 times g prime of 4 is 1/2. And then I can evaluate f of 2. So f of 2 is 1/2. Okay, 1/2 times 1/2 is 1/4 is my solution here. So work step by step like this. So write the derivative out means write out the expression using our function notation and then start to make substitutions. Same thing here. So r prime of 2, well, r of x is the square root of f of x. So r prime, well, first I'm going to rewrite this as f of x to the 1/2. And then r prime is going to be 1/2 f of x to the negative 1/2 power times f prime of x. Okay, and now if I want r prime of 2, I can plug that in. So equals 1/2 times f of 2 to the negative 1/2 times f prime of 2. And then I can start to make substitutions. So f of 2 is 1/2, and then f prime of 2 is 8. And here I don't have two functions in my table, so I can just plug everything in all at once. Lots of 1/2s in this example. F prime of 2 is 8. And then we could simplify this. So what we get here, believe it or not, and you can do this on your calculator, 1/2 to the negative 2 is 4. Or 1/2 to the negative 1/2 is 4, I should say. Okay. So anytime you have a function within a function, you're going to use chain. And when in doubt, write out the derivative expression. That's going to help you solve these. Okay. And we're going to move on to a graphical example. Students really struggle with these. This is going to be our last one. So again, we're going to write out the example, write out the expression. So h prime, notice I have a function inside of a function here. H prime of x is going to be f prime of g of x times g prime of x. And then notice I need three things here. I need g of x, g prime of x, and f prime of x. I'm going to write those out. So we're plugging in 0, h prime of 0. Okay, so remember we have to do the inside first, and then use the graph of f for the outside. So g of 0 is going to be the y value at 0 from the graph. So that's down here. G of 0 is negative 2. G prime of 0, remember that's going to be the slope at 0. So it looks like we're going down 2 to the right 3, so negative 3 over 2. So I can plug those in first. H prime of 0 then is f prime of g of 0 times g prime of 0, negative 3/2. Then f prime of negative 2, remember that's going to be the slope at x equals negative 2. Looks like that slope from the graph, we're going down 1 over 1 is negative 1. So same as we did in the previous page, this is just a graphical example. Remember, the derivative in these graphs is the slope of the line.